Right, so the first thing I did is I labeled the two tensions T1 and T2. Next thing I'm going to do is a free body diagram. I'm going to start with block A. Block A, we've got the mass of A times G. With two-body problems, it's really important to have subscripts. So I'm going to call that the normal of A. I've got the tension 1 headed this direction and tension 2 headed this direction. And then for B, I've got, again, MBG. Got the normal force of B. And I've got tension 2. So the next step is our force equations. So that sum of the forces is equal to MA. And I'm going to do the parallel and the perpendicular directions. So let's go ahead and take a look at parallel direction first. So we have, I'm going to make down the hill be positive. So I have T2 plus MAG minus T1 is equal to MA. Oh shoot, I left off the sine theta part. And the MA will be 0 because it's not moving. Then in the perpendicular direction, I have the normal force minus MAG cosine theta is equal to MA, and that will be also equal to 0. Then for this one, I am going to have in the parallel direction MBG sine theta minus T2 equals MA. That'll be 0 because it's not moving. And then the normal force minus MBG cosine theta is equal to MBA, also 0. Okay, so the first thing it asks us to do is to solve for the t's. So let's go ahead and do that. So T2 is equal to MBG sine theta. And we're done because we don't have any numbers, so we can just leave it like that. So that's the tension 2. And we're using our own equations to solve these. Then to figure out tension 1 is going to be equal to MAG sine theta plus T2. But T2 is equal to MB G sine theta. So now we have T1. Then it asks us to find all the normal forces. So we take this equation and we get the normal force of A is equal to MA G cosine theta. And we take this equation and we get the normal force of B is equal to MB G cosine theta. Then the last thing it asks us to do is to say what happens if it's flat. So if it's flat, then the cosine of 0 degrees is 1, and the normal force is just equal to mg, and that's true for both of them. And the tension, the sine is going to be 0 if we have 0 degrees, which means there is no tension. So if it's lying flat, the tensions go away, which makes sense because it doesn't have to strain against anything. Then it also asks for what if we have 90 degrees? So in other words, vertical. So if it's vertical, cosine of 90 degrees is 0. So the normal force is 0. So it's just hanging there. And then if we have the tension part, if this is 90 degrees, then we have 1. So our tension is just going to be equal to the weights that are being supported.